Hello, my dear students of Class 8. This is Priyanka Upadhyay, your physics teacher, and today we are going to continue our second chapter from ICSE Class 8 Physics, that is Physical Quantities and Measurements. In the previous video, we have studied about density and units of density. We have studied about density as a characteristic property of a substance, and we have learned about the determination of density of solids and liquid, and even we have studied about relative density. And today in this session we are going to learn about the law of flotation. Before understanding the law of flotation, in the previous video we have learned something about buoyant force or upthrust. Okay, and even we have studied that when bodies floats and sinks. See here, when buoyant force, that is upthrust, is greater than the weight of the object, the bodies floats. Okay, and when the buoyant force or the upthrust is lesser than the weight of the object, the bodies sinks in the liquid. And the third condition is when the buoyant force is equal to the weight of the object, then the body floats just under the surface of a liquid. So we have already studied about this, and today we are going to learn about the law of flotation. Okay students, so let us study about the law of flotation. The law of flotation states that a body floats in a liquid only when its weight is balanced by the weight of the liquid displaced by the immersed part of the body. It means weight of the floating object is equal to the weight of the displaced liquid. The amount of displaced liquid should be equal to the weight of the body. Then only the body floats, and hence the apparent weight of this floating body will be equal to 0. Okay, so we have an experiment, we have a video for this, so just look into the video.
Today, I'm going to show you a simple science experiment that you can try at home to learn about density. Start by taking an empty glass and tip in some water and food colouring. Then add some syrup or treacle. And I'm going to add a little bit more water to make the layer a bit thicker. Then finally, fill the glass up with some oil and leave it to settle for about 15 minutes. These liquids separate out into different layers because they're different densities and they don't mix. The syrup has the highest density, so it sits on the bottom, and the oil, which has the lowest density, rises to the top. Try dropping different objects in to see what happens. If we drop this metal nut in, which is really dense, you can see it sinks right to the bottom. But if I take this grape and drop it in, it sinks through the oil and water but sits on the syrup. This is because the syrup is denser than the grape. Pretty cool, huh? Now if I take this plastic bottle top and drop it in, it slowly sinks through the oil and sits on the water. And finally, if I take this piece of sponge and drop it in, it sits on top. The oil is denser than the sponge. You can try dropping different objects in to see which fluids are denser. I also found shining a torch beam down from above gives a really nice effect. I hope you've enjoyed watching this video. If you want to see more, you can click on the links on the right-hand side, or take a look at my YouTube channel page. Stay safe, have fun, and as always, thanks for watching.
Okay children, so now we will learn about some of the applications of flotation. See here, usually we see that the first one is flotation of iron ships. See here, usually an iron nail sinks in the water, but ship does not sink. Ship always floats on the water. This is actually because of the weight of the water displaced by the nail is less than the weight of the nail. See here, what is the condition for the flotation? The weight of the water displaced should be equal to the weight of the floating object. Okay, then only the objects will float. But in this case, the problem is the weight of the nail is greater than that of the water displaced by it, and that is the reason iron nail sinks in the water. And on the other hand, the weight of the water displaced by the ship is equal to the weight of the ship. Therefore, a ship floats in the water. See here, the condition for the flotation satisfies. What happens? The weight of the liquid, that is water, displaced by the object, that is ship, is equal. Therefore, ship floats in the water. For this, we will go through one video. Please look into it.
Topic: Archimedes Principle. Why do ships float?
Good question. Give me minimum 5 years to unravel its mystery.
Alright, don't bother. To answer this question, we need to understand Archimedes' Principle. Archimedes' Principle states that an object partly or fully immersed in a liquid experiences an upward force called buoyant force, which is equal to the weight of the liquid displaced by it.
Oh man, it is too complicated.
Okay, wait, I'll explain. A ship has a long and wide base due to which the amount and the weight of water displaced by it increases. Now, according to Archimedes' Principle, the buoyant force is equal to the weight of displaced liquid. Hence, as the weight of displaced water increases, the buoyant force, that is the upward force exerted by the water, increases, making the ship float.
Okay students, the next application is flotation in seawater. See here, it is easier to swim in the seawater compared to fresh water. It is because the seawater is denser than the fresh water. That is, in the seawater, the salts are being dissolved. So that is the reason seawater is denser compared to the fresh water. Okay students, our next application is flotation of fish. Fishes have swim bladders. These swim bladders are responsible for intake and release of the gases. When the gases are released from the swim bladder, the volume of the swim bladder decreases. And if the swim bladder intakes the gases, the volume of the swim bladder increases. Hence, by decreasing or by increasing the volume of the swim bladder, fish adjust the average density to the desired level, and therefore they can float at any level in the water. And our next application is flotation of iceberg. See here, many times we can see that the icebergs floats on the water. This is because of the less density of the ice. See here, the density of ice is lesser than that of the density of water. So therefore, the icebergs floats on the water. And we see many icebergs in the seawater, and those icebergs in that only 1 out of the 10 parts of volume of iceberg is seen above the seawater, and 9 parts out of the 10 parts by the volume remain inside the seawater. Okay, the last application is flotation of man. See here, the average density of the human body is less than that of water. The density of the human body is less than that of the water. That is the reason, as we know that less denser substances floats on water. We know about this. Okay, so therefore the human body floats in the water, but the head being heavier tends to sink. Therefore, the swimmers use their feet and arms to keep their head above the water. In the case of other animals, the average density of the body is less than that of the water. That is the reason they swim in the water. Okay. Okay students, our last part of this chapter is hydrometer. Hydrometer is a device which is used to measure the density of liquids. See here, the hydrometer have the lower bulb. Okay, as it is shown in the figure, just look at this pointer. It is the lower bulb. Okay, so it is made by heavy filling with the mercury or lead. Okay, so what happens? The thin narrow stem is graduated in such a manner that the mark up to which it sinks give the value of relative density of the liquid in which it is floating. So when you immerse the hydrometer in the liquid, so there are some graduations. Okay, so these readings give you the relative density of the liquid. Okay, so there are some special hydrometers that are designed to test the purity of the milk, or a battery which is fully charged or not. Those are acid battery hydrometers. Okay, so this is about a hydrometer. It is a simple device which is used to measure the density of liquids. Okay. Okay students, so in the next video we will discuss about the numericals. Till then, bye, take care.